everybody. Welcome to another edition of Angular DC. Today, I have the pleasure of hosting Sean Ramocki. Hi, Sean.
Hi, Don. How are you doing?
Pretty good.
Well,
How are things going with you? Absolutely.
Yeah,
Thanks.
things are going great. I'm just really happy to have this opportunity to kind of show you guys some TypeORM integration with NestJS. It's pretty cool.
That's awesome. Looking forward to it very much so. How long have you been interested in JavaScript stuff?
I've probably been working with JavaScript maybe the past, I want to say 3.5, 4 years. I originally started with C++, worked my way down Java as most people usually do, right? And then found JavaScript was the solution, right? JavaScript's pretty fun. There's lots of really good frameworks out there, and there's a lot of really cool things you can do. And it's really been probably my more passionate language in the recent times, right? Yeah, love it.
Yeah, it is interesting that you call it fun. Why do you think that is?
Just because I feel like there's so many opportunities of new things you can do in different ways, right? Versus, let's say, like a language like Java, you have like your set frameworks, right, that have been kind of in development for so long. But you look at JavaScript, you look at new projects that come up, and they've only been around for a couple of years, maybe a couple of months. Someone's created a new dependency that you can use and just start your project with, and I think that's just a really cool experience. Obviously, it's not without any downsides. I'm sure most people know the issues with the npm package manager and so forth, and security vulnerabilities, especially in recent times. But despite that, it's very, very cool to get things running off the ground very fast and share them with people. And that's really what it's all about, right?
Absolutely, yeah, definitely. Being able to deliver results pretty quickly is very valuable, especially to non-technical people, right? Because that's the only way they can really appreciate what we do. All the technical mumbo jumbo that we love to talk about. Really, people who use our software could care less about.
Right, of course.
It's I always try to liken or draw parallels between software engineering and like civil engineering, right? You don't really care about what went into the foundation of a building as you're just walking into it. You're just using it, and you have these set of expectations. And of course, the one thing about civil engineering is if you make a big mistake and your building collapses or your bridge collapses, that has life and death ramifications for people, of course. But then you're held accountable to that. And I feel like that's our software has grown to a point where mistakes in our software does have life and death ramifications. But I feel like we're not held anywhere near that same level of or similar level of accountability.
Right.
I didn't mean to turn it dark, from npm packages and exciting JavaScript stuff to life and death implications of software. But what do you think about that?
I mean, I will say this. There's a reason why they're still using Java instead of vehicles, right, instead of JavaScript, just for security perspectives, right, and stuff like that. But I think as those rough edges kind of get smoothed out over the years, right, as people kind of develop a better solution to handle those security vulnerabilities, especially since they've been so prevalent recently. I think probably more industries will start moving towards JavaScript as well, just because it's really popular for web development and so forth, application development. But for more like legacy application work, right, more closer to like civil engineering, right, more larger scale, more critical infrastructure stuff. I mean, there's definitely possibility for development work there and for things to be switched over, especially as those paths are kind of laid out, right? Because people love working in those languages, right? They just need that opportunity, essentially.
Yeah. All right, nice. Well, let me do a quick intro of the meetup, and then I will introduce you formally, Sean, and I'll hand the reins over to you for your talk. Sound good?
Yeah, sounds good to me.
All right. Okie doke, everybody. Welcome to the Angular DC meetup. You can join the group on meetup.com on Angular, meetup.com/AngularDC. We do have a code of conduct. You can check it out on github.com, AngularDC/code of conduct. So we encourage everyone to engage in the comments. If you have questions for Sean and such, please post those questions, and I will relay those questions to him, and we'll get those answered. And also, hang on until the end because we're doing an exciting giveaway of Wallaby.js and Quokka licenses. All right. So our prime meetup sponsor is Excella. We are hiring, including fully remote positions. You can check out which positions are available right now at excella.com/careers. All right. So last month, or rather this month, earlier this month, Angular 14 was released. What are your thoughts about it? Please feel free to post that in the chat. The preview for standalone components were part of the release. I think that's by far the single most exciting thing about Angular 14. But outside of that, of course, every 6 months, you should be upgrading your major version of Angular. The more you do it, the easier it becomes, and the delta between releases becomes smaller and smaller, so it becomes less risky. And it is a timed schedule thing, so you can actually plan out and budget to do this every 6 months. So highly recommend it. If you want to speak on this meetup, please DM at AngularDC for speaking opportunities. Share your ideas, and we'd be happy to have you on board. Otherwise, if you're hiring, looking for a job, or anything relevant, open source JavaScript related, please feel free to mention those in the comments as well. Thank you for joining us live. One thing I want to plug here is the NGXP podcast. Recently, or rather yesterday, the latest episode dropped featuring me. So I talk about my Angular journey and in general my journey from Turkey to becoming a U.S. citizen here. It is hosted by Eric Slack and Brooke Avery, wonderful hosts, and they're also heavily involved in organizing ngconf. So check that out, ngxp.show. It is available on any podcast platform out there. All right, so we do have the Wallaby.js and Quokka.js license giveaway. Wallaby is our Raffle sponsor for the meetup, and they create awesome software developer productivity tools. And I'm a huge fan of Quokka because it gives you a REPL environment for TypeScript, writing your VS Code IDE. So I'm a fan. All right. So and also Wallaby can be used to run your unit tests real time. So that's also a pretty neat tool as well. Okie doke. So today we have Sean Ramocki talking about getting started with TypeORM. TypeORM is an object-relational mapping software, and he'll be talking about how you can use this within the NestJS framework, which is a server-side framework leveraging Node and Express and TypeScript, and has very similar concepts to Angular, like dependency injection and other features that can use to write your APIs. Sean is a senior consultant at Excella, and he's been excelling at writing software since 2014. He developed a passion for writing backend code. Since then, he has worked with several Fortune 500 companies, and we're fortunate to have him. And he hails from Detroit, Michigan. And you can check him out on github.com at SR or S Ramocki. All right, and with that, Sean, if you want to share your screen, I will add that to you.
All right.
We'll hand the reins over to you.
All right, great. So thank you, Johan, for setting me up. So first I want to quickly talk about the tools and the frameworks I'm going to be working with before we kind of jump into the actual purpose of this talk. So as Dohan mentioned, right, we're going to be using NestJS, and NestJS is that server-side TypeScript-based framework that we can use for Node.js. The reason why I've chosen this in this case is just because it kind of goes hand in hand with the implementation for connecting to an ORM or a database, right? It creates a really nice experience for developers to create easy applications that are relatively simple to build, are very efficient and really reliable in terms of performance. But more importantly, right, for developing for the enterprise or commercial space, right, they're very scalable, right? And what that means, for developers, that you can create something once and then expect it to scale at a reasonable size, right, and still work just as you would expect. This is their homepage right here. As you can see, this is nestjs.com. Has a nice picture of a cat. They have a great documentations, which you can check out here, that kind of walk you through all the different parts of the application. I reference this documentation all the time when I'm working with NestJS stuff. It's actually really good. You won't really have to check around too many other websites if you want to get started, just because they do cover almost all those basic topics you want to know about when you're starting. As Dohan had mentioned, right, they do this NestJS is similar to Angular, in fact, because of its modules and its dependency injection setup. So if you're familiar with Angular, you won't have much difficulty kind of switching over to NestJS. And yeah, then our ORM that we're going to be using in this case is TypeORM, and their website is typeorm.io. Just like NestJS, they have really good documentation on their website, right? TypeORM is a really useful ORM that can run for NestJS, right? It's not just exclusive NestJS, though I should say this too. It's very extendable, and it's able to be used across many different versions of JavaScript, right? And TypeScript. It's usable within the browser, Node.js, many different tools that support this, right? And the most important thing, or the reason why that it's preferential for TypeScript, is because a lot of the implementation is kind of built around that. It's easy to create things on the fly and kind of set things up from there, just similar to NestJS, right? So they kind of go in hand in hand. With that said, I'm going to go ahead and switch my screen over to VS Code. And we're going to take a look at the project, and we're going to kind of walk through what we'll be doing today. All right, so I've created this sample project for NestJS with TypeORM. And essentially what the goal of this project here is, and that we're going to be walking through, is just to understand what it looks like to set the basic project with NestJS with integration with TypeORM, and how to kind of walk you through that initial set phase, right? Getting the necessary packages, creating the necessary configuration to connect to your database. From there, we'll be talking about how to actually create those initial first entities, right? And those entities are those objects that get mapped into the database, which is where the ORM part comes from the TypeORM name, right? And from there, we're going to be looking at those REST API endpoints, how they return data from the repository, right? How they save data in the repository, and all the cool different queries and types of things we can kind of do there to modify our objects, right? All right, well, that was a lot I kind of threw at once, but let's first take a look at the initial setup, right? So in this case, we can kind of skip over the initial creation of a NestJS project. If you do want to learn more, I do recommend checking out the website I just showed of nestjs.com. That'll get you started with actually, checking out and creating your first NestJS project. But for the sake of time, I will just kind of show you what we have here and walk you through the actual setup of integrating TypeORM with NestJS. So the first thing we want to take a look at is our package.json, right? As most people are familiar that work with JavaScript and TypeScript. This will be a TypeScript project, though, in this case. So the first thing we want to look at is the necessary dependencies, right? There's a couple different dependencies that we're going to want to make use of for this project that will come into play with TypeORM. The first being TypeORM itself, right? In this case, I'm using the latest version of 0.3.6, I think, which is from, I believe, maybe a couple months ago this time, maybe April. Next package that's really important too is PG, which stands for Postgres. There is another Postgres project or package within the npm repository, right, called Postgres, spelled out, but That's been deprecated in favor of PG, which also stands for Postgres. So that's one you want to check out here. The next one I do recommend is the .env. This will let you to simplify the creation of your configuration files. I won't be tackling that in this project, but I do highly recommend that, especially for something that you will be creating that will be going live into an environment, right? It's something that's not just being done locally. The next thing I have here is the class validator package. What this allows us to do is add some validation into our DTOs, right? So our data transfer objects, when we're actually, doing those creation and update calls for REST API logic, right? We want to do some validation of the data that we're sending. And the last one here I have called crossbar. This one is specific to Windows, so if you're not on Windows, I would just not worry about this one. And I will kind of talk to that when we get there. So once you have all your packages installed, you're ready to actually start setting up your project. And the first thing that we want to do here is create our ORM configuration file, right? And what the ORM configuration file is it's the necessary file that our dependency injection is actually going to be looking for to actually create that connection to the database, right? So let me explain. So I'll first open up this file. And what we're looking at here is the configurations of the actual database for TypeORM, right? And there's a couple different fields in here. We're not going to talk about all those just yet. We'll come back to some of those at a later time in this talk. But just the basics of this array is that we're defining it in data source objects. And the data source object is from the TypeORM package, right? That's just basically specifying those fields that are necessary to connect to a TypeORM. I'm using TypeORM to connect to our database in this case. As I mentioned previously, right, we're using Postgres. TypeORM supports more than just Postgres, right? It supports both relational and non-relational databases, right? So there's lots of support in there, which is another wonderful reason why it's so useful. But for the sake of this project, we're just using Postgres. So as you can see here, I'm naming up my type of the database, the host, the port, username, and a database name itself. For entities and migrations, we will come back to those. But just assume this is necessary for connecting, right? Once we've created this configuration, right, we go ahead and actually make use of it in our app module, right? So we actually have to import it. So as part of the configuration step, right, we have a for root method that we can call. And from there, we want to specify the imported data source options that we've specified in that separate configuration file. And what this is going to allow us to do, right, is essentially make that connection to the database when we first start up our application, which is what you would want to do, right, if you had a database connected to your application, because otherwise your application will fail. And this is really useful too, because let's say if you made an error in your data source option, where there's an outage or there's invalid credentials, it's going to reject you and let you know that you can't log in, and your application will fail to start. Okay, so that's pretty simple, right? Not too bad for getting started. But the next thing we want to do is also go back to our package.json file, because we have scripts that are necessary to use, right? And that first script being TypeORM itself. Now, there's a little confusion in regard to the current documentation of TypeORM, and specifically what the correct command is that you would want to use to actually execute TypeORM, just because they've deprecated some things recently. What I would recommend is just using tsnode. This is what most people will recommend online as well. It's the best way to execute your TypeScript files, just because it'll support the transcompiling JavaScript files as well. So if you're executing this on both JavaScript and TypeScript files, it'll work just fine. So that's what I would recommend for now. Okay, and let's move on. Next, I want to talk about the actual creation of those entities, right? Because once you have your connection to the database, you actually need entities, right? Because entities will represent your tables in the database. So that's critical to actually making use of the ORM, right? So in this project here, I've created two separate resources, right? Resources is the terminology used in NestJS to represent that folder, which represents the controller, the entity, the DTO, the service, and the module. So in this case, I have created a person and car resource, right? So let's first take a look at the person, just because the person is relatively simple. Let's first take a look at the controllers, and then the services before we take a look at the entity. So first, looking at the controller, right? This is pretty standard for most REST API work done either in Java or JavaScript, right? We have the different HTTP methods, right? Then we have the calls to the services. In this case with NestJS, it's a little bit cleaner, right? We can specify the return type, which in this case will be asynchronous. In this case, it'll be a promise of the object, right? In this case, we are doing the basic, HTTP methods here of getting all people, getting a single person, creating a single person, updating a single person, and then deleting a single person. And then I have an example query that we'll be using in a little bit, but not just yet. Let's go ahead and take a look at the entity first, actually, before we step in the service, just so we can explain how that logic works. So one of the really cool things about TypeORM is that it both supports the active record pattern, which is essentially defining all your query methods within the model itself, and the data mapper pattern, which is using separate classes. In this case, I'll be using the data mapper pattern just because it's pretty standardly used, but you do have that flexibility, which some people prefer either way. I believe it's one of the only ORMs for TypeScript/JavaScript that supports that at the time. So I think that's pretty cool. In this case, this is a data mapper example, right? Because we're only specifying the actual entity itself here, and then I've created a constructor. We'll do the actual repository work within the service, which is aligned with the data mapper pattern, right? Where we kind of separate those two things out. Now, the first thing to note is when we create an entity, we actually have to use this entity annotation here. This is specifying to us that this will be an entity class as it gets picked up by our synchronization, which happens with TypeORM. Part of that process is done as the application starts up, and the second part is also done when we run migrations, and we will talk about that shortly. Once we've actually created this class here, we want to define the fields. As you would with most databases, right, you want a primary column. In this case, I'm using the primary generated column, right, which is one of those tools in Postgres. Since I'm not specifying how this primary column is being generated, right, automatically it's going to be numerical starting at 1 and incrementing by 1. If you wanted to change this to, let's say, using the UUID, they do support that as well. There's different options and parameters you can use for these annotations, right? And I would definitely recommend checking out that really amazing documentation I kind of highlighted earlier, just because it does have so many really good examples for all those different use cases, right? Because I assume most people will not be using this, primary generated column with a number. Most people probably would want to use a UUID. But for the simple case that we're looking at here, we're just going to be using that number, and that's fine. As I mentioned before, this is a person class, right? So the fields that I've created here is the ID. So how can we actually indicate who this person is by a number? Their first name, which is a string, and their last name, which is also a string. Then we have a field for their age, which in this case, I'm listing this as a number. And then I'm also doing a one-to-many relationship, right? So as I mentioned earlier, I also have that resource of a car. And in this case, one person can have one-to-many cars, right? Or technically, I guess it should be zero-to-many, but in this case, I've done one-to-many, right? So essentially, one person can have one or more cars. And in this case, I've also created some constructors, which will be used for the unit testing, which we will also get to in a little bit. Just to quickly kind of talk about this one-to-many relationship, though. In this case, we're defining that the person entity is being tied directly to that car entity, right? So if I scroll to the top, you can see I've actually imported that car entity, right? Because in this case, we're binding the property to the actual object. In this case, where we are setting the cars object as an array of cars, right? Just because there could be multiple cars. And I've also included an additional property here called eager, which I will be demonstrating off shortly. And what eager does essentially is it will allow the data to be returned automatically. Because let's say we do a left join, right? If we do like a standard left join, we will return the data that's associated with the relationship, right? And in this case, this will automatically return all that list of cars, right, for this specific person. But if we set eager to false, it would not return the data. This allows us to prevent, writing additional queries. Let's say we want to, return that data without having to write additional, left join. We can do this automatically now with this eager call. And that's just listed here as a property. One really important thing to note here too also is that by default, you have to be very specific with both the naming convention and the nullability of your columns, right, in an entity. And what I mean by that is that by default in TypeORM, any column you've created, the name will be automatically generated from that property name, which in this case it can violate the standard practice for Postgres, right? So you could have invalid characters that don't work correctly. So in certain cases where your name convention is not easily translated, you might want to modify that. And the second part is if things by all these columns by default are set to nullable is false. So if you want something to be nullable, you actually have to add that additional property here. So in this case, I would add the curly braces rate and do nullable and then do true. And then this is going to allow me to create an object of a person and not give them a first name. But since I don't want that to be true, right, I'm going to go ahead and do that. So we don't really care about that just yet. And we'll go ahead and save that logic change there. And then from here, I've kind of walked through the basic entity example. So let me go ahead and move back to the controller, and then we'll kind of talk through those service calls, right? So in the first the first controller call, we have the method for getting all people. And this is, of course, returning a promise since this is an asynchronous call. And what this is doing essentially is it's calling our person service called get all people. We inject the service in our controller class right here by adding to the constructor of the controller, right? So you can see here I've set it to private and read only just because we only want access to the specific class. And those statements are actually imported up above as well. So I switch over to the actual service here. We can take a look at the implementation. As I mentioned before, since we're using that data mapper approach, we have the repository separated out from the actual entity itself. And when I mean the repository, I also mean all those query methods, right? By default, within TypeORM, you will get several, when I say several, probably about 20 some methods will come out of the box for your repository, right? They've been standardized by the API. And these will allow you to basically do the general queries that you would need to do. There's also support for your own custom queries, right, with the query builder. And on top of it, there's some more advanced objects such as the query runner, which will allow you to connect to your database in real time and then actually write out your SQL statements in strings. And we can kind of highlight that with the migration work that we'll talk about in just a little bit. Okay, so as we've opened up our service class here, you can see that I've annotated this as injectable. This is part of the NestJS framework, right? Letting us know that this service is injectable into our module as part of the dependency injection. The second most thing important to note for TypeORM specifically is that within our constructor, we're using the inject repository annotation here. This is allowing us to actually call and create that repository specific to this entity that we're using in this case, which is the person. So you can see here I'm specifying the person entity. And also labeling this as a private person repository of type repository. This is, again, imported from the TypeORM package, right? And I'm casting it to type person. Once I've done that, that'll allow me to write statements using this person repository, and then call all those necessary methods to query the data or update data as needed be. So as we came from the previous controller class, right, we were looking at the get all people API call. Our first method that we would want to be looking at here is the get all people, since this is the method that gets called by that get request, right? In this case, we're just calling the method of .find. And .find is pretty straightforward, right? It finds all entities. We're not passing any properties or arguments into this method, right? There are additional options to do so, and I do recommend, again, checking out that documentation for the exact use case that you want to find. But here, this will just return all the data from that specific table. In this case, we're just returning as a promise, which is a people's array, right? the next controller statement we have here is the get by ID. So in this case, we're passing in that ID. This is, again, very similar to the get all people, but in this case, we're only looking for one specific person, and we're looking for them by their ID, right? And in this case, this parameter is coming in as a string, so we do need to cast it to a number. So we'll just use that number method, right, to cast it. And then we look back at that service. We can see we've done, again, something very similar here, but this time we're using find one by. And what this allows us to do is it looks for a condition, right? Otherwise, if it doesn't find the person, it returns null, as it says right here in the documentation. And what I've done here is I've used an await statement where I'm going to be looking to the repository. I'm going to be finding this person based on the property of ID. I don't have to just use ID. I could also use first name, last name, age, right? I could do age, for example, since that's also a number. But that's not going to be valid since we're passing in only their ID, which I will revert back to. As I just said here, this is an await command because we want the response to return back before we store this in the constant variable of person. If this person variable is not null, then we want to return it back. Otherwise, we're going to be throwing an HTTP exception. Now, this is something that NestJS does, and it's very cool and pretty awesome, I have to say. There's custom HTTP exception handling within NestJS, which is done automatically. And as an addition to that, you also have the option to create your own. And it's pretty straightforward and pretty significant use cases, right? So in this case, I could create any custom logic that I wanted to handle this API endpoint. In this case, it's very simple. We just know the person's not found, so we're returning that 404. But if we had a more complicated business example, right, we could use any one of those HTTP responses that are available, right? So we could go for any number of those different codes. There's many in there, right? And there's many different use cases, right? So if your API expands and grows, lots of these will be applied to you. So I'll go ahead and revert that back. And when I say that they handled the HTTP exception, what I mean is that when we throw this exception, it's going to be passed as the response to that actual API call. And let me go ahead and show what that looks like. So first, I'm going to go ahead and start up the application here. Actually, no, before we do that, let's come back to starting up the application just because I haven't created the migrations yet. So we'll go ahead and first talk through these services, and then we'll go ahead and look at that migrations. And then we can kind of come back to here and play around with that. But what I wanted to mention for the HTTP exception handling is that NestJS has their own internal filtering, which will kind of handle those exceptions for us between those asynchronous calls. And it will properly output them where they needed to actually be used instead of failing the application. Okay, and next API call I want to talk about is the post call. Very similar, right, to normal REST API calls, right, where we're taking that body, which is the DTO of the create person object. And here in the DTO, we have the field specified, right, the first name, the last name, and the age. We have some validation for the annotations from that class validator package that I mentioned earlier. It's very straightforward and very powerful, right? So we have the option to check if something is not empty. And if I highlight that, it'll tell you that it'll check if it's not equal to null or undefined. We also have the option to check to see if something is a string. We can check, if there's a minimum value or a maximum value. We can check if something is an integer. The sky's the limit. I think there's a couple hundred different annotations from the class validator package, so it's really great. Now, if we take a look back at the service, right, the controller, we're passing that DTO, right, which has validation on it, and then we're going into that create person service. So we go back to the actual service here. Our method is pretty straightforward again, just like the get service we have in here as well. So in this case, we're calling the create method. Create method just creates the object rate. Doesn't actually save in the repository, but what it'll do is it'll take that DTO in and format it to the actual type of object that will be represented in the repository if it does get saved. From here, we're going to go ahead and actually save this and then return the data. Very straightforward. And the same thing is true also for the update call, which we're using in this case as the put. We're taking in the body, which represents that the update person DTO. But the thing that we're doing differently here is we're taking the ID of the person, right? Because we also need to specify what person we're updating. So in this case, we are Also converting that string into a number because it represents the ID. We take a look at the actual update service. There's a little bit of different logic done here, right? Because first, we actually have to call the update method. We're going to wait for this to finish because this is actually going to be potentially saving data into a repository, right? And if we take a look at the create person here, you can see I actually call the create method. We don't actually have to wait for this to finish because this is not an asynchronous call, right? This is just going to be formatting the object that we're passing in, and we're going to be storing this variable. Versus when we actually return the variable, this is where the actual asynchronous call is happening. But since it's in the same line as the return, we can omit that line. I mean that verbiage. But if you look back at the update person line, as you can see here, we actually have to wait for that finishing before we can move on to the next line. And from here, the next thing we want to do is after we've updated that, we want to see if that person truly exists in the repository, right? Because what if they don't? So to actually handle that here, we're going to first call that find by one, which we use in the service up above. We're going to take in that ID, and then we're going to see if that person exists. If it does, we return it. Otherwise, we should do some error handling, which it doesn't look like we have here, but that's what we should be implementing, right? So we let the person know that person has not been updated. Moving on, moving back to the controller, the last verbiage that I want to talk about here is the actual delete. Delete's a little bit of a different case just because the response handling in NestJS is a little undocumented. But the sky's open to you as a developer to handle this in any which way you want. So again, we pass in that parameter representing the ID of the person we want to delete, which is pretty straightforward. We again convert that string to a number, and then we call that delete person service. The delete person service is just when we go ahead and call that delete method, right? Passing that ID. From here, we're actually going to get a response because this is actually not going to be a person, right? This is going to give us a delete result. Now, the delete result has very little documentation on it, unfortunately, but what's apparent from the documentation at least is that it has a numerical attribute called affected. And I'm sorry, it has a numerical attribute called raw, and then you have the number of rows affected. But you also have a Boolean value called affected as well. In this case, I'm using that Boolean value, which is representing if anything has been deleted or not, right? So in this case, if nothing has been deleted, I'm going to go ahead for an HTTP exception, and this will handle back the correct response to my API with a 404, letting them know that the person was not found. But on the other hand, if that person was deleted, I'm going to go ahead and return a object to them, letting them know that the deleted action is true. So in this case, I'm not returning a person back because it wouldn't make sense to return that person since they've been deleted. But instead, we either have a response of them not found or a response of the message being true. So in this case, the responses do vary a little bit. And of course, we could specify a custom type of object to handle both use cases, but that might be left open to a future developer to work on. Okay, cool. So that was the basics of getting up the service through the controller and the entity. But you might be wondering, how do we actually set this up in the module, right? So that's the last thing we want to talk about before we move on. So let's go and take a look at the module, right? Now with dependency injection, right, we do have to list out our imports, our controllers, and our providers. This is again pretty similar to Angular. In this case, our providers are the service, right, our person service. The controller is just our person service. And our import in this case is actually specific to TypeORM only. And this is again going to be actually making use of the entity that we've defined here. So whenever we have this for-feature method call, we want to list the array of objects or entities that we're going to be using in this specific module. And that's going to allow us to actually kind of model our data for these service calls, right? Which is the purpose of this integration. And from here, once you've actually created this module, you want to go ahead and actually add this to your app module as well. That way, the dependency tree working as you one would expect. So you can see here below my for root where I've imported my database connection settings, I'm actually including the person module and also the card module too. You also might notice I also have the app controller and app service. Those are just generated out of the box from the NestJS application. You can ignore those. believe there's like a hello world API endpoint for a get call.
Sean, Paul had a question. I don't know if you just answered it, but he's asking, I may have missed it, but do we need to register the repository into the module, or is that done in the .for root we registered?
That's a good question. Yes, that is what I just mentioned. So whenever we have this for root call in our module, this is where we're actually registering the entity for the repository.
Awesome. Thanks.
Mm-hmm. Okay, cool. So now that we've kind of talked about our basic entities, working through our basic REST API endpoints, let's actually talk about setting this application up and working with migrations. So the first thing I want to do is actually, I'm going to talk about migrations first. So what is a migration, right? Most of you are familiar with migrations in terms of, kind of bringing changes in your code base up to par with your database, right? So TypeORM is no exception in that, right? You're going to be having migrations just the same. But one thing that's really cool about TypeORM that's pretty different from what I've seen in other ORMs, right, is you have both the creation of a migration rate and the generation of a migration. Now, what does that mean, right? Well, the creation of migration is what it sounds like, right? It's what would be pretty standard for almost every other ORM. You have your SQL statement, right? You execute that either on application runtime or with a separate pipeline, right, or commands, and that's going to be bringing your database up to par with whatever you specified. Now, that's a little tedious, though, right? Not everyone's a fan of doing that because that's very manual work, right? That's where the generation comes in. The generation is a really cool feature in TypeORM where it will automatically scan your schema for database changes, right, versus your entities in your code base. And from there, it's going to go ahead and generate those SQL statements for you. And all you have to do from there is just run them, right? And then it'll bring your database up to charge. So let's first talk about the actual commands for executing those migrations, right? So we look back at our TypeORM, we look back at our package.json file here. As I mentioned before, we're using tsnode for actually executing our TypeORM commands. And I've actually created 4 separate commands for running migrations, right? We have one for the creation events, the generation events, the running, and the reversion, or revert. Now, in this case, we can first start with the create commands, and then we'll work our way down. So the first thing you need to do here is just open up your terminal. You're going to go ahead and type npm run, followed by migration create. Now, the really cool thing that I've done here that is, well, this workaround is specific to Windows, but if you're not using Windows, this isn't something you have to worry about. But with npm, you do have the option to specify input arguments right in your command line. And in this case, I actually can specify the name of the output file. This is a workaround for a recent issue, I believe, that's been introduced in the most recent TypeORM, where previously there was an option for CLI arguments, right? So if I look back at my TypeORM configuration file here, there was previously an option for specifying the output of your migration files. That no longer is functioning. It's been deprecated. So instead, as a workaround, you actually can specify the output through your package.json file, and using your actual naming convention to specify the output file name. So in this case here, if I walk through my create command here, I've included this option called crossbar. As I said, this is specific to Windows, and what this allows me to do is to execute this input command right on Windows and have it run just fine. I'm going ahead and using tsnode, as I mentioned before, all the way through to the migration create command. The reason why I'm not using TypeORM in the previous script above is just because here I'm specifying the actual ORM configuration file, which I do not need and is actually not allowed in the create command. So there's a little bit of confusion with the scripts that you have to write here, but it's very important that you are very specific in how you write this out, or they will not work correctly. Lastly, I'm following this by the actual output path of the migrations of where I want them, right? And then this is the actual input argument that I'm going to be using to specify the name of the file. So if I scroll up here and kind of minimize some of my folders, this migrations folder, And then from here, I can specify the name to be, let's say, test1, right? Go ahead and execute that. And awesome. Test1 has been successfully generated. Now, the first thing when you look at that file name is you might be wondering what all those numbers are, right? Well, that's just the time in milliseconds, right? That's just the timestamp of the file. And once you've created that file, right, you have two different methods that are automatically created for you. You have the up command and the down command. The up command is what gets automatically run when you execute the migration run command. And as you would expect, the down command is for the migration reverts, right? So whenever, let's say, migration fails or there's an error, the reverts should be automatically run. So it's really important. I would say this is really good best practice too, is when you're creating your migration scripts yourself, is that you both create the you always create the down as well as in addition to the up command. As I mentioned previously, right, with this query runner commands or this query runner object, you have the option to actually execute your SQL commands in line with string. So we go ahead and actually run it here. You can see that I have a lot of different methods for specifying the data transfers or the data manipulations within the database, right? Again, I would recommend looking at the documentation just because there's so many different things you can do here. You can drop columns, you can drop a database, you can just execute commands. There's so many things you can do here. But the main thing that I want to highlight here, which is what the generated SQL commands will also do, is they run this method called query, right? And then from here, they actually can type out the actual SQL command in text, right? Executes a given SQL query and returns the database results. Oh, I'm sorry, that's not the correct command to actually execute that. But I would say check out the documentation because there is so many different things you can do here. Yeah. Now moving on, let me go ahead and delete this file. Next thing I want to show is the actual migration generate, right? Because we have created this entity in here, right? This person entity. But if I go ahead and open up the database, right, there'll be nothing there because let's say this is the first time we've set the project. In my PG admin, there's no tables created in the schema for this object yet, just because I've never booted this application up yet. So the first thing we would want to do is first generate those entities, right? Because we actually want to create that migration. So to do this, I'm going to go back to my package.json file, and let's look at how we would set up that generate command. In this case here, I'm also using the cross-var package to allow me to take that input command for Windows, so I can actually name that file. In this case here, I do want to use that argument for specifying the configuration of the database, just because in this case, the generate will be connecting to the database while it runs this command as it synchronizes, right? So it's going to be really critical to correctly outputting that. Now, in this case here, I'm going to go ahead and just type migration generate. We'll just give this a 2. So you will see this from time to time, right? No changes in the database were found. And the problem that comes from here is because you've actually never booted up your application the first time. And you've never built out your files too, right? So going back to how this actually operates, right? So let's take a look at the configuration file. So this is where it's critical to next talk about the remainder of the configuration file, right? So as I mentioned before, the first couple lines right here, these are just connecting to the actual database itself. But the remainder here are specific to both the synchronization of the application as well as how the migrations operate. The first line we have here is the actual entities of the application. And this corresponds to the entities that are loaded, right? As you can see here, it says the entities that are loaded for this connection. And as the application boots up, as the migrations run, it's looking for the JavaScript files, right? Just because there's some technical nonsense where you can't have a mixture of TypeScript and JavaScript files at the same time in the configuration file. It doesn't operate correctly. It'll fail on you during application runtime. So in order to standardize things, it's recommended to both do things in JavaScript. In this case, I've specified the distribution folder, right? Because that's where things are transcompiled. And I've enabled logging, so I'll know what happens when I actually boot up my application and run migrations. Synchronization is also set to false. Synchronization, what this means is that when the application is booted up the first time, I'm sorry, not when it's booted up the first time, when the application is booted up and it's set to true, then what's going to happen is all the entities will be synchronized with the database automatically without creating any migrations. In smaller case applications, this might make sense for you, but for larger applications where you want to keep track of all the changes you're working on, it does not make sense to use that. And the next command is migrations run. And what this means is that automatically when our application is booted up, the migrations will run. Again, this is also not recommended for more larger scale applications, just because ideally you'd want to separate your migration pipeline from the actual application, right? Just because, let's say if you have distributed servers, so things are kept in sync. Also kind of decoupling that work just so you can keep the application running. The next line we have here is the migrations argument, right? This is going to be pointing to where those migration files are. Let's say you actually execute that migration run command. It's going to be looking for that JavaScript file. And the last one we have is the migrations table name, right? Called history. That corresponds to the table in the actual database, which will keep all the history of the application, right? So without further ado, let me go ahead and start up the application, and then we'll look at the actual migration generation. So you can see here when I first start up the application, it's going to be generating that distributed folder, right? That'll contain all the entities of the application. So we go ahead and scroll up here, look at source, look at person, look at entity. We have the entity here listed in JavaScript, so it's been generated, right? Now if I go ahead and terminate this application, let's go ahead and try generating one more time. Aha, so look at that. Now it works, right? Because now it knows that JavaScript file exists, right? It knows there's a different full file that exists now that also doesn't exist in the database. So it has to make two separate checks, right? That's a really important gotcha too for dealing with both JavaScript or TypeScript files. Because it's one thing that the file doesn't actually exist in the database, but it's another where it actually can't find the entity file. Because if it doesn't know where the entity file exists, then there's nothing for it to check in the database, right? Because that table has no comparison point. Okay, so let's take a look at that generated file. As you see here, we have the query method that's being called in the query runner. And it's just going to be running essentially plain text SQL commands, right? So it's very simple to write these. And it's also very simple to generate them too. Again, it's going to be naming this file based off the passed in argument, where I name this test2. And it's going to be including the timestamp, right? So you can see here the file name is the timestamp dash the test2 name that I had given it. When I actually execute this migration run, it'll be executing the up method here. And if I execute migration reverse, it'll be executing the down as well. Now that I've created this migration file here, I have a file that I can actually execute, right? Because automatically this doesn't actually do anything. It just creates the file for me locally. If we look through the actual commands that's generated, right, you can see that it's creating a table called person. ID is serial, not null. The first name is a character vary, not null. As I mentioned before, right, since I had not specified it being a nullable field, it's automatically not null as a constraint. As you can see here, if I scroll through, primary key is ID. Okay, cool. So next, let me go ahead and execute these migrations files, at least this migration file, and then we can take a look at those API endpoints in action, right? So let me go ahead and go back to my scripts, right? So let's talk about those two last scripts. The last script we have here is called migration run, and the one beneath that is called migration revert. Now, as you see here, I have two scripts that actually run here. The second being, npm run TypeORM migration run, but the first being npm run build. Now, you might be wondering, why do I have build in here, right? Why does this application have to be built if it's actually not running? Well, one of the unfortunate downsides of dealing with JavaScript when you're in TypeScript, right, is that you actually have to compile it first. And since with that configuration file being pointed on the JavaScript file, if I was to execute just the npm run TypeORM migration run, where it was pointed in that distribution folder, right, you can see here there's no folder called migration, right? Sorry, actually I have to open up source first, but there's no folder called migrations, right? So essentially nothing would be migrated. It would fail. But as a workaround, if we rebuild that folder out, we'll have that file ready for us to use. So I'm going to go ahead and execute that now. So we'll do migration run, migration run. See, it's building. And it has committed successfully. As you can see here, the file has been executed. Just to demonstrate that, let me go ahead and switch my screen over to PG admin, just so we can take a look at that quickly. Okay, so now I'm on PG admin right here. I'm going to go ahead and refresh. As you can see here, I'm connected to my database, which is called Postgres. I'm going to go to my public schema here. I scroll down, refresh my tables. You can see I have my car table, my person table, and the history table. And then there's also a metadata field, but we won't worry about that. If I open up the history table here, you'll see that there is one run listed with the first integer right here, and then the timestamp of the file. If you recall correctly, that's the same timestamp corresponding to the file. Actually, it's listed right next to it. As you can, yeah, so it's a correct timestamp of the file that we had used to execute. So this is corresponding to the correct migration that we ran, which is awesome. We go ahead and expand the columns here. We can see the IDs here, the first name is here, the last name, and the age. So all 4 columns have appeared just as we expected, right? So let me go ahead and jump back. Let's go ahead and take a look back at the application. Because now we're going to go ahead and start the application up. So I'm going to go ahead and type in npm start. Application's been started. Let me go ahead and close these things out here since we don't need to look at those anymore. Now, to help speed up development time, or at least locally test this, I've created this request.http file. This is really awesome for quickly running your API calls locally, right? And there's a great extension that you can find in the extension store, which will execute these for you as well. Going through my API calls here, as I kind of reviewed earlier, right? We have the get, we have the create, we have the update, and then delete. If I click the get all, you'll know that I return an empty array, right? Just because I haven't created any people yet. So we'll go ahead and execute that first. So I have this post call here with my body. It's me. I'm really old, which is okay. I'll go ahead and click send request. And as expected, it's returned back that person back to me, right? I'm currently ID number 1, because this is the first person that's been created. If I change my name to 2 at the end, I made myself really old. Actually, I don't want to be that old. Let's say I'm 45 now. And we send that one more time. You can see now the ID has increased to 2, which implies our Postgres increments, or the serial command in Postgres, right, is executing as expected, right? And if we went back to the get all people, we would see that it would return the array of both people, right? Or I guess my clone and myself. If we execute the get by ID, where I'm calling the ID of 1, it should only return the 1 person, which it does. As I mentioned earlier, right, when we were talking about the eager field, right, on the car array, where we had the one-to-many relationship rate of the number of cars, since I have set this as eager, right, it's going to be returning that array of cars here when I specifically return the individual object. As you can see here, my car array is empty since I have no cars yet, but we can fix that. If I scroll down, I also have a separate resource called car, which I don't know if we'll have time to talk about today, but it's very similar to person, other than it is sharing that relationship, right? So here I can create this car object. It's a Toyota Venza, and I'm going to be sending this to person 1. So I'll go ahead and send that request. You can also see that returns back the year and color, because those are other fields as well. But in this case, I've allowed these fields to be nullable, which you can see here, it's be returning as null since they were not set. And if I was to go back to the get single person call here and run that one more time. Oh, sorry, that was creating person. If I go back to if I scroll up just a little bit more and click create person by ID, you'll see that it returns that car array with just a single car, because in this case, I only have 1 car, which is what I want, which is great. Now, what if I want to delete person, right? Let's say I delete person 3, because I don't think I wanted to create that 3rd person. So we say delete is true. Let's change it to 2 now. Delete is true. But let's say 55, right? So let's test that error handling that I mentioned previously. Because we don't have a person with ID of 55. It's going to give us that handled HTTP exception that we created, right? Called person not found. Again, this is a really simple use case, but as you can imagine, it's very powerful in what you can do with it. In this case, I just sent a simple message back with a 404 response code, but I think that has serious implications and it's very useful. Okay, cool. So very quickly, since I know we're almost out of time, there's one more cool thing I do want to quickly show. So I go back to my person controller. Let me open in this window. Close this out. I have this one HTTP verb down here called patch. This is actually not a patch. This is just used for testing. But in this case, I'm actually running a test query, right? And this test query is going to be defined in our service. If I scroll in here, you can see I've defined it. So this is me using something that's more out of the box versus one of those default methods on the repository. Here I have the option to create the query builder, right? Where the query builder is essentially allowing us to customize our query through methods, right? Instead of actually using plain text. This is an alternative to the query runners we saw in the migration file, right? Where we actually ran in plain text. This is more secure, right? As you can imagine, there's no room for error here. You're very specific in your terminology. In this case, I am doing a left inner join, and I'm only getting one person back. So if I went back to that controller right here, and we tested this call out, you can see that it's only getting one person back with the car. Now, we only have one person with one car at this time, so we don't know how true that really is, right? So let's get all people. We can see there's only one person. So maybe let's create a second person. And that person has an ID of 4. And let's go ahead and assign this car to them. Now, if we were to go ahead and do the get all request one more time, you would see that now there's 2 people and each person has 1 car. Now, if we went to the test query, right, for that left inner join, which only returned 1 entity, and let me go ahead and open this up in another window so we don't lose it, so I can explain this one more time. So this is again a left join on select, right? So left join select is going to be returning the object that's it's going to be essentially doing equivalent to the eager load, right? Where it's going to be returning the objects and the related objects, right? That share that one-to-many relationship. Now, if eager was set to false, this would still return the same data on the right as it would if it was eager. So this is an alternative to eager, right? Because you might not necessarily want eager on all the time for performance considerations. And as you can see here by this last line, the get 1, I'm only be returning 1 object and not 2. So we go back to the request here and execute this. You can see it only returns 1 person and not 2, even though there are 2 people that have a car. Another option is your inner join and select. This is the option to not return the car object, right? And you also have more options, right, with a standard SQL query, right? You can do a where command. You can specify the name of the property you're looking for. In this case, what I've commented out here is the first name is equal to Sean, right? So this guy's the limit, essentially. And with that said, this is everything I wanted to talk about. So I will pass it back over to you, Johan. Thank you.
All right, thanks a bunch, Sean. That was awesome, and very thorough. It feels like anyone who's just starting to use these tools can take a lot away from this and get going on their way. So thank you. You're muted, Sean.
Sorry, I muted now.
Okay, well, it's time to do our raffle. We have JR and Matt who opted into the raffle. Any other folks who wants to opt in, please say so in the comments. Unfortunately, due to government regulations and such, not everyone is eligible to receive such gifts. So you gotta opt in. All right, and also Dave is saying that he'd like to, I guess, have one more talk from Sean, perhaps going deeper into things.
Yeah, there's plenty to talk about still. There's the unit test, right, with mocking the repository, and there's a lot of advanced topics in there. TypeORM, the documentation page, it keeps scrolling down and it doesn't end, right? So there's a lot of things in there.
Absolutely, and Bob is saying requests that HTTP is a great testing tool.
Yep, it's critical. I think it'll save you a lot of time.
All right. All right, and Matt says, great presentation. So,
thanks, Matt.
All right, and yes, we added Dave to the raffle as well. So we have JR, Matt, and Dave as part of the raffle, and I'll give like 10 more seconds to join. Then we'll do it. The odds are pretty high. Someone will be the recipient. So the first one will be for the first person will be for I guess Quokka, and then the second person will be for Wallaby. And I need to remember to record the winners. So, all right. Okie doke. Let's do this. Let's do this. Let me share my screen for a change. Window, there you go. All right, so Dave is asking a question while I do this. Is there a huge difference between TypeORM and micro-ORM?
I'm not familiar with micro-ORM, but I can definitely look into that. Is that a fork of TypeORM?
I am not sure. Dave, I guess if you could let us know, that would be much appreciated. And we have our winners. JR is the winner for the Quokka license, and Dave is the winner for the Wallaby license. So to receive your license, please DM me on Twitter @Deluca, and I will share the link to your license for you. And meanwhile, Dave is looking up the URL for micro-ORM. And let me also look it up. I have it on the screen, I think. Is this it? So micro-ORM seems to be a .NET tool. I'm not sure if it's compatible with a TypeScript solution. So is there a huge difference between them? I'll just say in general oh, okay. I guess it's micro with a K.
Right.
But I'll say in general with these tools, the devil is in the details always. So most of these tools, even if they look similar or the difference in behavior, there'll be tons of gotchas along the way. Having used and authored an ORM, and more of an ODM, I can say that the devil is in the details. So, okie doke. Well, thanks so much, everybody. Thank you, Sean. And
thank you,
everyone.
Thank you for having me.
Have a great day.
Thank you, everyone.